Hello viewers, in this program I will discuss about physical properties of minerals. I will discuss about the physical properties of minerals which are based on state of aggregation. Next important property is cleavage. What is cleavage? Cleavage is a tendency of a mineral to break parallel to atomic planes, and these planes are smooth surfaces. These breaking of the mineral, they break along the smooth surfaces. Surfaces must be smooth, then only we call it as cleavage. The cleavage or the parting is controlled by internal structure of the mineral, and cleavage planes are often parallel to one or more crystallographic directions. Viewers, as you know very well, there are three crystallographic directions A, B and C. So, you have crystallographic planes also. So, breaking of the minerals along or parallel to a certain plane is important, and in their habit they break up along certain planes, and these are the planes which also display the weaknesses in the lattice structures, weaknesses in the lattice structure of a mineral. Cleavage are of different types. What are those? First is prismatic, when parting is parallel to the prism. Basal cleavage, it is parallel to A and B axis and across the C axis. Third one is parting or false cleavage, as seen in case of corundum, pyroxene and garnet. They show false cleavage. It is not a cleavage, but it looks like a cleavage. So, there are three different types of cleavages: prismatic, basal, and third one is parting or false cleavage. Now, cleavage, this property is very common in mineral, and it depends upon the direction. Sometimes you have the partings or cleavage along the 6 directions, 4 directions, 3 directions, 2 directions, 1 direction, or sometimes poorly developed, or sometimes it is there is no cleavage developed in the mineral. So, all the conditions are possible in the nature. So, 6 direction, when the cleavage is in 6 direction, we call it a 6 directional cleavage. Example is sphalerite. The partings or cleavages are parallel to dodecahedral faces. There are minerals where cleavages are or the partings is possible in 4 direction, we call it 4 direction cleavage. Such cleavages are found in fluorite. In case of 4 sided or 4 directional cleavages, it is parallel to octahedral phase. When it is parallel to 3 directions, we call it as 3 directional cleavage, as in case of halite, galena. These are the 2 examples, calcite, dolomite. Certain cases we get cleavages only in 2 directions. Example is pyroxene, where cleavage is of 2 direction. What is the angle between the 2 direction? That is 124 degree, and prismatic cleavage, we call it as prismatic cleavage. Another example is feldspar, where we get cleavage parallel to the faces and they are at right angles to each other or 90 degrees. Kyanite is also a mineral which shows 2 directional cleavages, and if you remember, the hardness of the kyanite in these 2 directions is also different. What does it reflect? The weaknesses in the planes of the lattice structure. Now, 1 directional cleavage is seen in case of mica, topaz, only one direction. There is no second direction along which mineral can be broken up. Then cleavage is poorly developed, neither it is completely developed nor it is not developed, it is poorly developed. Some of the planes are developed, but other surfaces are broken or irregular. So, we call it as poorly developed. Example is nepheline and leucite. And there are certain minerals where no cleavage is developed. There is no cleavage which is developed. There are minerals when there is no cleavages. It is not necessary that all the minerals do have cleavages. What are those minerals where you do not find cleavages? They are quartz and olivine. Quartz sometimes shows conchoidal fracture, but no cleavage. I am showing you a picture of a 3 sets of cleavages. They are developed here. One is in this direction, second is in this direction, and third one is in this direction. So, there are 3 sets of cleavages developed in this rock. As I said earlier, there are minerals without cleavages. You can see amorphous mineral, but no cleavage is developed here. This is hand drawn figure where I can show you one direction cleavage. This one direction cleavage, you see this cursor carefully, this is one direction cleavage along which mineral can be separated or the crystals can be separated easily, and this is a plane surface. When it is separated, it is a plane surface like this. This is also a separated surface. Then second is the 2 directional cleavage. This is 2 directional cleavage, one direction is this one, second direction is this one. So, in drawing this is one direction and the second cleavage is perpendicular to the horizontal direction. This is horizontal direction and this another set of cleavage is perpendicular to the horizontal surface. So, there are 2 directional cleavages. Now, 3 directional cleavage. 3 directional cleavage, what are the directions? You see, this is one direction of cleavage which is on the surface of the specimen, second direction is this one, and third direction of cleavage along which parting is easy is this one. This is the third direction. So, you have direction 1 along which mineral can be separated easily or the planes can be separated. This is second direction and this is the third direction. It is the line picture of a all the 3 directions, horizontal direction, vertical direction, and this is across the length of the specimen. Now, another important property which is also commonly seen in case of minerals is striations. What are these striations? Striations, they are the structures basically represented by thin parallel lines or furrows or crystal faces. It forms due to succession of narrow planes meeting at an angle and producing mini ridges. So, striation is a regular feature and it is represented by a thin parallel line. This is a structure or furrows developed over the crystal faces. Any crystal faces you may find that striations are developed, and furrows or ridges or grooves they are developed, but these grooves and ridges they are aligned together. They are not isolated, but they are aligned in a one particular direction. Such types of structures are called striations. Striations are very well developed in minerals like quartz, tourmaline and pyrite. Here I am trying to show you the striations. It is it is a crystal face of a quartz. This is a quartz crystal here. This is a quartz crystal. You see entire picture of a quartz crystal, and this is the face of the quartz. You see carefully, this is the face of a quartz. On this face of the quartz, these are the grooves or ridges. You have one groove here, you have ridges here, grooves, ridges, they are developed in a regular manner, and such structures or such features are called as striations. This is another example of a tourmaline. Tourmaline, as I said earlier, they develop, tourmaline develop, faces develop, most common faces are prismatic faces, and along prismatic faces, this is a prismatic face of a tourmaline crystal, along which the parting is also very common, or cleavages are also developed, but this is not a cleavage, but it is striations. Striation means on this prismatic surface of the tourmaline crystal, these ridges or grooves are developed. These dark black colored grooves alternately developed, grooves and furrows developed over the prismatic face of a tourmaline. So, such structures are called striations. Here is a picture of very well developed striations in pyrite. This entire specimen is of a pyrite, but here the pyrite face, very well developed pyrite face shows grooves or striations. See carefully, these are the grooves alternating with ridges or the eminences and depressions, they are aligned in a particular direction. These are the grooves and ridges in pyrite. Now, I will discuss about a quartz crystal. Here is a picture of a quartz crystal, natural crystal, and in this quartz crystal these are the faces developed over this. These are the important faces of a quartz, and if you see this face carefully, there are certain ridges and grooves and minor trenches developed over these. See this cursor carefully, these are the ridges, dark colored ridges developed over this face of a quartz. So, these are the striations found in the natural minerals. Now, another important property is fracture. In my previous slides, I have discussed about the cleavage. Now, I am discussing about the fracture. Fracture and cleavage. Fracture is also a important property, but important for poor or no cleavage minerals. When cleavage is poorly developed or not developed, the broken surface is irregular. What is the difference between fracture and cleavage? The most important difference between fracture and cleavage, in case of fracture, the broken surface is irregular. It is uneven surface, ups and downs, no smooth surface. But in case of cleavage, you may find a smooth surface, no ups and downs, no irregular surface, but it is a smooth surface. So, this is the only difference between fracture and cleavages. In case of cleavage, surface will be smooth, but in case of fracture, the broken surface will be rough or uneven. This is the major difference. Fracture pattern is distinct and highly diagnostic in mineral identification. We use this property in identification of minerals. The most common fractures which are seen in minerals are cited here. So, there are 3 columns: fracture, description and minerals. I will take up one by one. Conchoidal fracture. Conchoidal means fracture of a grass. When a mineral breaks up and the breaking of mineral is similar to the glass, we call it as conchoidal fracture. Irregular, smooth, broken surfaces resemble to broken glass with a curved concave or convex fracture. Such surfaces or such type of fracture is called conchoidal fracture. Example is obsidian. Obsidian is a rock actually, it is a natural glass, and quartz and flint, they show conchoidal fracture. Uneven fracture, when you have rough, uneven, irregular, broken surface with slight elevation and depression, we call it as uneven fracture. Majority of the minerals, they show uneven fracture. Even fractures, flat surfaces are there, but you should be careful, these flat surfaces are distinct. They are not similar to the flat surfaces of a cleavage. They are dissimilar in the sense that these flat surfaces are rough, whereas in case of cleavages, these flat surfaces, although they are flat surfaces, but those flat surfaces of cleavages are smooth, that is the major difference. Now, another category of fracture is fibrous or splintery. Fibrous fracture of a fiber shown along fracture surfaces. The example is asbestos. When you break up the surface, you may find the fractured surface is very much similar to the thread like surface. So, we call it as fibrous fracture. Hackley, another category is Hackley. Hackley fracture is a broken surface with rough zagged edges or broken across its length. That is very important, it is broken across its length. Hackley fracture is very common in iron, native copper or kyanite. They display Hackley fracture. Then lastly, earthy. Earthy fracture, broken dull surfaces. The broken surfaces are dull, they are not shining. So, such fractures are called earthy fracture. The best example is chalk or clay minerals, they display earthy fracture. So, viewers, you have different categories of fractures: conchoidal fracture, uneven fracture, even, fibrous or splintery, Hackley, earthy fractures. All the different categories of fractures can be distinguished by their different configurations of the surface, and I have also given the common examples, these fractures found in certain mineral species, which I have already given in this table. Here is the picture which shows conchoidal fracture. See carefully, this surface is a broken surface, it does not show any regular or even surface, but it resembles very closely with the broken surface of a glass. So, this is called conchoidal fracture. Viewers, in this program I have discussed physical properties of minerals based on state of aggregation, which includes cleavage, striations and fracture. Thank you very much.